Good evening, welcome at the Logos Foundation for another webcast. This time will be very different than last times. Last times we have always been presenting new works for the robot orchestra, but this time I want to give you an insight in how the robots are actually made. So we are here in the Logos workshop for instrument building, where we do metal work, woodwork. We will make organ pipes, where we make actually the instruments. So the instrument we are presenting tonight is an instrument that's still in the making, and one of the easiest ones actually to make. So please, if you have ideas, this is a way to go. We also tried to document a way of making organs, in this case, in a very cheap way, in a way that's not really prohibitive in terms of material cost. So what is involved? First of all, if you want to make an organ kind of instrument, apart from the pipes and the pipework, etc., is of course that you need wind. Now you can do wind in very different ways. You can do the oldest and the most traditional way, use the bellows that you move up and down, like I have a bellow here, clock. So like on the accordion, you can make this move up and down to make wind. The problem is, if you want a steady wind flow, then you need two bellows, because when it is changing direction, the air pressure will go to zero, and so you would have a problem. So you need something with over and back going. So that involves already a motor with a thing that does like this to go up and down, which is a pretty complicated thing mechanically to make, particularly if you want to work it to make it such that it works silently, which is something quite essential for a musical instrument. The alternative is, and that's what we, for the most of our robots, we've been using so far, apart from the accordions, you can use a radial compressor, which is the machine I have here. It's a three-phase motor, and then there is a rotator, so radial compressor, etc. That gives a steady flow of air. This motor is controlled by a board, a microprocessor board, that allows it to control the air pressure and the speed of rotation of the compressor very precisely. The motor has a silencing part, and here is a valve underneath that opens and closes according to the consumption of wind. Now, to stabilize the wind from here, we feed the wind still in a bellow. This is the bellow mechanism, so when this motor turns, this goes up, and there is a spring inside or a weight upside to stabilize the pressure, such that when you consume a lot of air, it will go down a bit and it will move according to air consumption. There is an output, there's actually two outputs on the bellow here. See, it's not finished, it's still to be closed. Here's an output. This goes to one of the wind chests, where the pipes live, and here's another one for the other wind chest. Now, let's look a little bit into the construction of the wind chests. And now we will go to the lower and the higher wind chest of this organ in the making. So here we are with the next step. Once we have the wind ready at a pressure that we anticipate of using for the organ, we need the wind chest, which is just a channel where the wind is and which is fed into the pipes. And of course we need a mechanism to turn it to musical instruments to switch the pipes, the air in the pipes, on and off. Now, the traditional way of doing this electrically is by using this kind of solenoid, which you can place over a hole in the wind chest there, and it opens and it closes, etc. But these things are pretty expensive. They are made specially for church organs and organs in general. You can buy them at Laukhof, but at a price of some 30 or 35 euros a piece. If you make a 100 pipe organ, this is a pretty expensive bill. Now, we found out that there is a way to do it very cheaply. That is, go to China, of course, and buy these valves. These valves, you can buy them at Banggood, I think, for $2 or maybe less if you buy them in quantities. They're made from plastic, from nylon, and there is also a solenoid here that activates an anchor inside that moves over a certain trajectory. These are made for half-inch pipes. Actually, that's a good size to use as an organ pipe switch. And here you see these cheap valves used on a wind chest. Now, you could, for small pipes, you could directly place them in top of the valve. You need no external parts. Of course, if you need larger organ pipes, you need to make some piece to connect the outlet of the valve to the organ pipe. This is what we did here with these brass thick nuts. So the organ pipe, I have here a B, a low B organ pipe. Now just stand here. And to secure them, we have a pipe holder here, and with some nylon straps we can just hold the pipe in place. Now, to make it work, it's just enough to feed some current, 12 volts, into here. You can have a minimum of expression control by applying a variable voltage to the coil here. So, for instance, at the onset, if you give an over voltage, then the valve will open and close with high speed. If you let the voltage go slowly up, then the valve will open slowly and you will have a slow speaking pipe. So you have some possibilities to control the expression of the organ this way. Now, okay, what I said about doing this with the voltage is of course not something we are going to do by hand. We want it computer controlled and preferably controlled by a MIDI data stream. To do that, we designed at Logos Foundation many different PC boards which all have a microcomputer. I'll give you an example here. Here's a single-sided board, easy to make yourself, and you can find all the details on the Logos website, on the manual and on the different instruments and the different organs. This is an example of a board capable of controlling 12 of these valves. So this board will actually be used to control the 12 organ pipes that fit into this wind chest. So this is a complicated board because it has this velocity control and these expressive possibilities for each individual pipe. This is not, of course, the end of the whole story. This is only the bass register, so from low C up to B. And then there is a second part with another over 100 pipes for the high pipes, the smaller pipes, etc. All controlled by a similar kind of boards. In this case, this type of board, which is a double-sided board, makes it a little bit smaller, etc. It's basically the same idea. So we need a couple of MOSFETs for every valve and a microprocessor to control them all, to convert the MIDI data into the switching patterns required to make the organ play. Okay, let's have a look to the wind chest for the high notes. And here, in another section of the Logos workshop, we see all the pipes that we are going to use for the high register. These are existing organ pipes from an organ that was demolished, etc., and we restored them all to reuse in this organ. Of course, if you want to go cheap or make everything yourself, you can make the organ pipes from PVC. It's pretty easy, and there's documentation also on the Logos website on how to approach this, but you can do it at virtually no cost with very cheap PVC pipe. Okay, but these are regular organ pipes, so these will all be mounted on the high wind chest, which has electrical valves that close in the way like from the Laukhoof valves that I showed you at the other wind chest. So we recycled those also, and these will be operated also with the PC boards and the microprocessors that we prepared for that purpose. Actually, if you want these boards, you can also buy them. You just send an email to the Robots Foundation, and we can make them on your order for whatever you like. You have to specify the kind of coils you want to use, the kind of solenoids you want to use, but that's about it. And the MIDI mapping eventually, unless you want to do the programming yourself. But the service is available from the Robots Foundation. So these pipes will all find their way on the wind chest there, which is now upside down, but we did that to make it clear for you what it looks like. When it's upside down, you see only the holes for the pipes, and that's not very interesting in terms of revealing the functioning. So, the guided tour to the workshop gave you some insight about how the organs are made. You know, in the robot orchestra, we have more than 10 of these organs, and the one we are making right now is projected to be ready by this summer, probably to go on the street for the Ghent feasts. It will be mounted on a trolley again so that we can take it outside and play for the people in the feasts. To give you an example of a composition where such an organ made after this recipe is used, I selected one of my older pieces, a fugue number 7, fugue septic, which is scored for quite a few of the orchestra, but also for the piperola organ, which is an organ that I made some more than 20 years ago. And it's been since then ever been working in the orchestra as a fixed member. Okay, that's it for tonight. For next week will be again a premiere, a new composition by Lisbeth de Krok for the Robot Orchestra. Good appetite!